Assalamualaikum warahmatullahi wabarakatuh. My name is HARITH Benderi. So this video for the assignment discrete signal and system. So we have 4 members. The second FAHMI bin SAADON, Muhammad FAIZ ZULKARNAIN, and also MOHAMAD NAZHIM. So for the objective, able to understand the Fourier transform, Gaussian kernel, and Laplacian of Gaussian kernel for image transformations, and also able to understand how convolution in image picture works. So in theory, the Fourier transform is important image processing tool which is used to decompose an image into its sine and cosine component. The output of transformation represents the image in Fourier of frequency domain, while the input image is the spatial domain equivalent. In the Fourier domain image, each point represents a particular frequency contained in spatial domain image. Next theory for Gaussian kernel, the Gaussian smoothing operation in 2D convolution operator that is used to blur image and remove the detail and noise. In this sense, it is similar to the means filter, but it uses different kernel that represent the shape of a Gaussian bell-shaped hub. So the theory for the Laplacian is a 2D isotropic measure of the second spatial derivation. Next, for the Laplacian is a 2D isotropic measure of the second spatial derivative of an image. The Laplacians of an image highlights a region of rapid intensity change and therefore often used for edge detection. Also, the Laplace is often applied to an image that has first been smoothed with something approximating a Gaussian smoothing filter in order to reduce its sensitivity to the noise.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad FAIZ bin Muhammad RUCHAINI. I'm from 2BET, section 1/2, and my matric number is B081910392. Today I will present about task 1 for the assignment discrete signal and system. So the first question for the task 1 is snap an image of one or all of your group members. This will be your original image. So our group use our original image. We use our fellow friends picture, which is a FAHMI SAADON. So this is our original image, as you can see here. So question number 2, visualize your original image into frequency domain using fast Fourier transform. And the question 3 is reconstruct the image to its real domain. So we go to the MATLAB. So this is a coding that I have write for the task 1, as you can see here. So for the instruction unread is stand for reading original image, which is we use our fellow friends pictures. So the instruction for the IM show is show the image. So for the coding, they will have 6 outputs, which is original image, gray image, Fourier transform of an image, center for transfer of image, log transform image, and reconstruct image. So I will run this coding and let's see the output. Okay, this is for the output of the picture original image, figure 1. As you can see here, this is a original image. For the second output is the gray image. As you can see here, the picture become a gray. Then the original image, they have a color. So the figure 3, as you can see here, this is a figure 3, which is output 3 for the transfer of image. They become a black picture. And the figure 4, which is output 4, the center for the transfer of image. If you look carefully, and you can see at the center of image there will be a dot, white dot here, as you can see here. So for the figure 5, output 5, log transform image, the image become a log transform image, as you can see here. And the last output, which is a figure 6, the reconstructed image, as you can see here. They will be same with the figure 2, which is output 2, the gray image. As you can see here. So this is task 1 output. You have a 6 output and the 6 different image, as you can see. Original image, gray image, for the transform of an image, log transform image, center for the transform of image, and reconstructed image. So that's all for me. And the task 2, my fellow friends NAZHIM will explain. Okay, thank you.
Assalamualaikum and hi. My name is Muhammad Nazhim bin Ali from BET as section 2/1, and my matrix number is B0819104334. So today I'm going to show you of the assignment of discrete signal system. So my part is task 2. So the question is, apply a blur effect on your original image using Gaussian kernel. Observe the changes in the output in image as you change the standard deviation value. So compare at least for output image with different standard deviation. So after that, this is the coding for task 2. So for this line, so for this line is to read an image into the workspace. So for the image, we use the image of our fellow friend. Then so for the next line is to filter the image with an isotropic Gaussian smoothing kernels. So this is the coding. So this coding will blur the effect into 3 image. Next, this is the coding for to display the original image and all the filtered image. And this is the coding of this for the smooth image. So there will be 3 images. First is sigma equals to 2. Next is sigma equals to 4, and finally sigma equals to 8. Okay, so for this coding, it is to filter the image with anisotropic Gaussian smoothing kernels. I am Gauss field, so record this command is to allow the Gaussian kernel to have different standard deviation along row and column dimensions. So then we type in the coding to display the image, the filter image. So there will be 4 images. And then this is the final line of the coding. Okay, so then we run it. Okay, so this is the image for original image. Figure. So this is the image of the original image. And then this is a image of the smooth image. Sigma equal to 2. And this is the image of smooth image. Sigma equals to 4. And this is the smooth image. Sigma equals to 8. And this is the blur image. So they have 4 type of image. For level of blur image, and this is the type of image that we get from the, this is the output of image that we get from the task. So that's all for me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is FAHMI bin SAADON from BET section 1/2. My metric number is B0819100079. So today I am going to present task 3 for assignment discrete signal and system. So the question asks about detect the edges of your original image using Laplacian of Gaussian LOG kernel. Observe the changes in the output image as you change the standard deviation value. Compare at least 4 output images with different standard deviation. Okay. So as you can see on my left side monitor, this is the coding that I have write. So the first line, the I'm read command is for reading my original image. I use my own picture as the original image, and the F special command is for Laplacian of Gaussian filter. So as you can see, this 0.2, 0.3, 0.4 and 0.5 is the sigma value. Okay, so when the value is different, you can see changes in the images. So I use 1, 2, 3, 4. I use 4 different values for sigma. And this coding I'm show is going to show the picture, the output. So there will be 1, 2, 3, 4, 5 output that will appear when I run this section, when I run this coding. So let's run this coding. Okay, as you can see, there are 5 output here. So the first one is the original image, and the second one LOG with sigma equal to 0.2. You can see it less darker than 0.3 and 0.3 image less darker than 0.4, and you can see the sigma value 0.5 have the darkest image between all of the output. So the higher the sigma value, the darker it will be, the image will be. So I think that's all from me. Thank you very much.
For the conclusion, after we done the task 1, 2, and task 3, so we can conclude that in task 1 that we can acknowledge that the Fourier transform is an important image processing tool which is used to decompose an image into its sine and cosine component. Low frequency contains more information than the higher one. Fourier image contains segment. All the things considered, yet their greatness get more modest for higher frequency. Also, Fourier transform image show that there are two dominating directions in Fourier image. This originates from the regular pattern in the background of the image. At task 2, we can assume that the output of the transformation is the higher the sigma, the picture will be more unclear or blurred. And at task 3, we can read up the output will have more capture edge when the sigma is lower. Thank you so much.